a second.
Mm.
Yes. So once this your train test split is completed, then we can jump into the next part, that is your creating your regression model. Okay. So what is your
Mhm.
regression model? Regression model is basically your, we will see it. Okay. For now you may think just is that like a machine learning model, in that you have to give your input, okay, input data set,
Mhm.
and it will do some
Mhm.
pre-processing. It will find some it will find some values, like here we are
Mhm.
doing mm, on this step, right? We are taking some learning rate and we are taking any random value, and our model will find that, will try to come at this particular point here,
Yes.
because this is
Mhm.
our this at this point our accuracy is high.
Yes.
So our model will try to come at this point. If you give the learning
Mhm.
rate very low, it will take very less time. If you will take very high, so it will jump here and there. Okay. So
Yeah.
our learning in our linear regression model, we'll try to basically find that exact value, or we will say this as a bias.
Mhm.
Sometimes we say
Mhm.
it as a let me think what the actual word is. Mm, uh, 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 we have a equation here in linear equation, that is your y is equals to mx plus c. Okay. So we will be seeing
Mhm.
this equation exactly how it works when we will be seeing this linear regression model. So in
Mhm.
this equation, basically this x is our this value of x is your features. Okay. So this
Dep-
x will be your independent variable. Okay. And y
Mhm.
will be your output. Okay. You may
Yeah.
think x will be your input,
Mhm.
y will be your output, and this x
Yes.
sorry m and c. Okay. These are the
Mhm.
values that will be helpful for predicting your output. Okay. So okay, so
Out.
to explain you how this work, I have to explain you this equation. Okay. So we are having this y is equals to mx plus c, right?
Mhm.
So in this equation, this y is your uh,
Output.
output.
Yeah.
Okay.
Output or
And this x is
intercept.
not is your basically input, but this is your independent variable. Okay. Independent
Mhm.
variable, like in this
Mhm.
example this is 1. Okay. So but most of the
Mhm.
time here in this case we are having 5, so it will be like m1x1 plus m2x2 plus m3x3 for number of independent variable, how many number of independent variable we will be having. Okay. And c is your bias. Okay. C will be some certain value, so a fixed value. Okay. So c will be that bias. Okay. And in our model, our machine learning model job is to find the value of this m and
Yes.
this c.
Yeah. Mhm.
Once this
Mhm.
value of m and c are you have find the value of this m and c, you are good to go. You're now you can actually predict the final output. Now you can tell what the
Yes.
output sorry, what the basically this exact output is. Using
Yeah.
this, now you can find the value of y
Yeah.
if you
Mhm.
have the value of m and c. So our machine learning model, this here we are having this linear regression model, has to find this value of m and c. Okay. So now
Okay.
we will fit our data x train. X train is our independent variables, and y is our dependent variable or predicted variable, basically, right? Target variable
Mhm.
y. Okay. So now LM is your regression model object. Now till here only your model is created, and now just is time to your if you can now just give your model, and mm, you can start predicting. Okay.
Mm.
Now you will evaluate your model, how accurate your model is. How you will do it? You will give your training data set, sorry, test data set to it. Okay.
Mhm.
So now I was
Mhm.
talking about that it was your intercept. This c, sometimes you may call it as bias, and sometimes you may call it as
Mhm.
intercept. Okay. Suppose say yes.
Okay.
So your machine learning model job was to find the value of this m and c, right? So using this dot intercept, you may see what the value of this C is, what this intercept value is after training this, after fitting this model to the for fitting the data to this model.
Okay.
Okay, so we have got this LM. This is basically your model now. Now this contains that model. Here we will give this input and it will give some output. Okay, this LM. Okay, and now if you want to check the intercept, now you can do this by writing lm dot intercept, and it is giving you some value, that is your minus 264015. This is your basically your intercept. Okay, and now you can predict some output. Okay, now here we want say we are saying x dot columns coefficient df. Okay, yes, so yes, so this x, right, so this m, right, so I was saying that this m is your coefficient. Here we have used if you remember this m1 x1 plus m2 x2, right. This will be this will be a number of your independent variables, right. So in our case there were 5 independent variables, right. 1 2 3 4 5 6, sorry 5. Okay, so we are having 5 independent variables. So here we will have m1 x1 x1 and it will go till 5.
Yeah.
Our equation will look something like this. Okay, and now this your 1 will be your 2 and this is your 3. So this will be your equation. So C will be your intercept, M will be your coefficient, coefficient 1, coefficient 2, coefficient 3, coefficient 4, coefficient 5. Okay, and C is your intercept. You can see the intercept is your this value, and if you want to see the coefficient, here you can find the coefficient is here we are converting that array of coefficient into pandas data frame. Okay, so that we can display it. Okay, so your lm dot coefficient, like similar to lm dot intercept, this lm dot intercept contains your intercept, lm dot coefficient contains your coefficient value. Okay, so here we are having 5 coefficient, right, 1 2 3 4 5 coefficient. M1 is your area, average area income. So your coefficient 1 is 21, coefficient 2 is your this value. Okay, so now whenever this we will get a new value like x1, we will get any value average area income. Okay,
Yeah.
that data will go inside this, will be replaced with this x1, and I get a new I will get some new data set. In that I am having x2 some new variable, new input for your average area house age, that will go inside this x2, m2 dot m2 multiplied x2. Okay, similarly for other variables as well. So this value will be replaced by that, and m1 will be replaced with this 21, m2 will be replaced with this this value, m3 will be replaced with this value, and similarly for 4 and 5, C will be replaced with this value, and this your equation will be completed, and after the calculation you will get a value that will be your price for that input. So this is how your linear regression works. Okay, now once we have built our model, now it's time to predictions. Okay, now we will predict the values. For predicting we are using lm dot predict. This was our model lm we are using dot predict. Inside this predict we are passing the test data set. The test is your 40% of your data, right? So this 40% of your data will be passed here. So these are your predictions. Okay, so this will contain an array of your data. Are you getting this, or are you confused like how it is working? Because
No, no, I'm good. Yeah.
okay.
No,
So
no, you go ahead. Yeah.
because prediction will contain your array of your output predicted value.
Okay.
Okay, so this will be your array. Like for if you remember, there were 40% data, right? So it will
Yes.
contain
Yeah.
the predictions for that 40% of your data. It is not one prediction. It is a prediction for that 40% of your data. It will be all stored in this predictions. Okay. Now you can scatter the plot a scatter plot, and in that scatter plot on the y-axis we are giving the y test. That is basically your original value. Remember,
Yeah.
original
Yeah.
value, and predictions are your predicted value.
Yes.
So this is the graph. You may see that it is like on a kind of linear. That means
Yes.
our model is pretty much accurate.
Yes.
Okay. On y-axis we have our original data, and on the x-axis we have original data, and the y-axis we have our predicted data, right? And now again you may draw a distribution plot. Okay. You may see that the shape is normally distributed, which means our model has done some good predictions, right?
Okay.
And this is your evaluation model, evaluation matrix. Okay, so at the evaluation we are using that mean absolute error that I showed you how it works. Why we multiply the values. Okay, so this is your squaring the data and then finding the mean of it. So this is your how it works. Okay, squared error, absolute error. What absolute error does is, see, in squared error we were squaring the values, right? In absolute error we will be taking the absolute value. Like it was -4, we will do it +4. We will do absolute value. Okay, so this is how this mean absolute error works. Okay, so that's why you would be seeing that this value is in a lower scale and this value is on a higher scale, because this is the squared value and this is the absolute value. Got it?
Yeah.
And this is your root mean squared error. If you will find the root of this again, you will get this value.
Yeah. Okay.
So these are the basically your metrics for evaluating your model, how accurate your model is. Right here we find the mean squared error, right? Mean squared error, the same code, and just using the numpy square root function, square root here.
Okay.
Okay, and then we are displaying it. Here we have the mean absolute error in the matrix. Here we are using a pre-written code, that is matrix inside sklearn. Inside this we have function mean underscore absolute errors. Here we are passing the, remember in parameter it takes original target value and predicted target value, right? So that's why that is then only it can be able to see the evaluate your model, right? You have to give the original data also, the real data also, and the predicted data also. Then only it can evaluate your model. Then it will find the it will compute the for every column, every row. Basically it will subtract the values and do perform the mathematical computations, and it will give you some values, right? Basically your MAE, or your mean absolute error, or your mean squared error. Okay, and if you will square it, it will give you mean squared error, RMSE. So this is how your whole process from basically a working of your machine learning happens. So this was important to understand, because it will give you confidence like how you work on your data, right? So once you got this
Yes.
complete workflow, now you can work on individual step on depth. Like now you can work on this cleaning data on depth, right? On this scaling in depth. Okay, now it depends on you, like how deep you want to go.
Yeah.
Okay, So from tomorrow we will see some algorithms. Okay, we will see some learning algorithms, and we will see the optimizing techniques for them, like how we can use the hyperparameters for those algorithms, right? And it will take like some algorithm, like we will see some linear, this same linear regression in some more detail, and we will see some tree algorithms as well if we get some time. And after completing
Okay.
that, we will start with a project that will contain some advanced stuff. Okay, in that project you will see some cleaning data also, scaling data also, means like we will be using all the concept that we have used. Okay.
Okay.
Yeah, any questions?
Yeah.
Yeah.
See, here we are using only one file. We can compare dependent value within that file, right?
Dependent value, yeah.
If
Hmm.
yeah, if you have
Hmm.
um, two or more files, the labeled value depends on those other features as well. Where it comes.
You are saying that
Yeah.
while you're working, we have collected data in the different files, right? In some files,
Yes. Different. Yes. Yeah. Yeah.
so basically we will
The
join them
labeled
first.
value depends on the other files. I'm sorry. Yeah.
So yeah,
Can I say that?
so yeah, yeah, please
Yeah.
say. Hmm.
Yeah. So the labeled value depends on the other files or other features from other files. So how does it work? Where it comes in these steps?
Yes, so it will come in your data
Yeah.
pre-processing in this part.
Oh,
Here we have
okay.
to add that
Before.
by using the file handling techniques of your Python, right? In
Mm-hmm.
Python we have a file handling, like by using that you can use the other files, right?
Mm-hmm.
Then you will read the basically lines of that file, or basically your CSV
Mm-hmm.
file, and then you will
Mm-hmm.
compile them. Like you may add them file basis on the particular column name. Suppose say you
Mm-hmm.
have a
Mm-hmm.
column name like your serial number column, common, right?
Mm-hmm.
On the basis of any common
Mm-hmm.
column, you will basically append them or concatenate them. Okay.
So
And
basically, it comes before training
yes, yes,
the
yes, yes,
model. Yeah.
exactly, exactly,
Okay.
right? Before training you
It
have to
will
do that.
come.
Hmm.
Yeah. Um,
Yes.
so in this case, the data pre-processing gives only one file.
Yes, like most of the time here we are
Yeah.
doing with one file.
Yeah. What
So
are
it,
that? Yes. Yeah.
so if that is the case, at the first of all we
Mm-hmm.
have to perform that step before cleaning also, right?
Mm-hmm.
Because only
Mm-hmm.
once we get the complete data, then only we can
Mm-hmm.
clean the data, and then we will perform this technique scaling data, right? Because that data may contain some uncleaned or missing value or
Yeah.
like this
Yeah.
stuff, right? And see, in most of the time in production what happens is we try to automate all these things. We will make a pipeline, like you will have a
Yeah.
pipeline in which your data will be incoming automatically,
Mm-hmm.
and it will be
Yes. Yes.
checking for every step, like do it contain this, even if it not contain, but still it will be checking, so that if any time we get any of the value that is not cleaned, of suppose say it contains some outliers, it will
Mm-hmm.
it will be passing through that step, it will be passing through that pipeline. So
Now
while
I got.
passing through that pipeline, it will be
Mm.
handling all those inconsistency at there only.
Okay. Okay. Now I got. Mm.
Okay. Yeah.
Yeah.
And next question,
So
any other? Yeah.
yeah, I'm good. Yeah, that's what only thing I'm thinking. Since usually we get so many files,
Yeah,
not
yeah,
only
yeah.
one file
Yes,
from the
yes, yes,
data,
yes. That
right?
is the
Yeah,
main.
in this
Oh, yeah.
case.
So in those file, at least one column should be common, right?
Yes, yeah.
You
Mm-hmm.
would be having any one column that will be a common, so that
Yes.
right, like it may be or name of that person, if that data is of about some person, because it,
Mm-hmm.
so that it can be appended, right? So that it may know that this column is talk about which basically which column.
Mm-hmm.
Are you getting my
Yeah,
this
yeah,
point or not?
Yeah, I got it. Yeah, we can. Yeah,
So it should have
yeah.
any
We will do
some
one.
common column. Just like
Yeah, right.
any column that is common. Okay. So yes. So
Yeah. You were trying to say something in the
mm,
last one. Decision tree or something. Yeah.
which thing?
Decision tree or something.
Yes,
You
yes, yes,
started
yes, yes,
saying
yes,
something.
yes, yes. So we will be seeing some learning algorithms like decision tree and your linear regression and some these algorithms, and we will try to see how you will be adjusting the hyperparameters and optimize it. Okay, basically, and then
Sure.
basically we will wind up with a project and we will deploy it if we get some time, like on a website creating by some website. Okay, so that
Okay.
you may understand how the deployment works. Okay, so
Yeah.
that's it for today's video.
Mm-hmm.
Sorry, today's session.
Okay.
Hope you would have find some insights or have learned something new today.
Sure, sure. Yeah, that's it. Yeah, yeah,
Okay,
yeah, yeah. Can you share that one? I will try the
yeah.
uh,
So the today's
course.
code.
Yeah. Mm-hmm.
Okay, 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 okay. So I will, after
Yeah,
this
and
class I will be sending. Yeah.
sure. Okay. Yeah, yeah.
Anything you were saying?
No, I'm good.
Okay. So I will be saying sharing with the these files after this class. Okay. Thank you.
Thank you. Thank you, Mr. Francis.
Okay.
See you tomorrow.
Okay. Bye.